Hello everyone. Good morning. Welcome to Ganit. I hope your preparations are going well. So we had started this 40-day booster sort of series for all the board exam students who are board students who are writing their exams for 10th grade. We had started with circles, as you already know. We're going to continue in that same series. Today, I think circles, we will try to wrap it up. Then we will also have questions from trigonometry after the circles are done. So let's just start with the questions, guys. And on the side of your solution, I'll keep writing all the important things which I would want you ideally to take a note of and keep practicing it. When you are practicing at home, when you are solving questions at home, I want you to use those things and see if it helps. I hope that it helps. Okay. So let's just start this question now. So we have this question where it says that O is the center. There are a few angles given to us, and then they have four different parts that they want us to find out. The first question, the first part says find the length of the PT. Okay, let's just start with this. So we have an angle 45 degree here, 50 degree here. So we know that from center to the point of contact, when you have a tangent, the angle is usually 90 degrees, right? So, and then they drew a separate line. So, and they gave this angle as 50 degree. That means this angle has to be 40 degree because the entire angle has to be 90 degree. Correct? So, the theorem I'm using is this. If this is your center, this is your tangent. So, radius is perpendicular to the tangent. So I have for 50 degree given to me. So I get this angle is 40 degree. Now, remember what we talked about in the last videos. This is an isosceles triangle. So we have this as 40 degree. So this will become 100 degrees. 40 plus 40 is 80. The remaining will be 100 degrees. Then we have something like this here. Sorry. So this is another angle made by the same arc. If you notice point T and point B. So this is AB. Now, if you notice, I have an angle at center. So angle at center is how much, guys? 100 degree. That means angle at the circumference would be half of it. Again, ninth grade theorem, correct? So we have this angle as 50 degrees. This angle was given to us as 45 degrees. This is given as 9. This is given as 16. Now, if you notice here, we have a 40 degree here. This is center O. Shouldn't this angle also be 50 degree? Because this is also the radius, correct? OB is also the radius. So we have 40 plus 50, 90. That means this and this will be equal. So if you notice, we have triangle PTB as isosceles, correct? Where PT is equals to PB because the angles were equal to each other. So we can say that the length of PT is 16. So the first part, A part, is 16 centimeter. Let's see if we have already found the angles that we were searching for. So angle BAT, that is this angle, guys. BAT, I think we have found it, 50 degrees, correct? So B part, angle BAT is 50 degrees. How? Angle at circumference is half of center angle. That's what I used here. Now, angle BOT, BOT. So they are talking about the angle at the center, which we have already figured out. Angle BOT is equals to 100 degree. What did we use for this? We used isosceles triangle formed by the radii. And then the last one they are asking us to find is angle ABT. ABT So that whole angle. Okay, so ABT means we will need this angle. So the D part, angle ABT, if you see on the diagram, we can write it as angle ABO plus angle OBT, and that angle ABO is 45 degrees and angle OBT is 40 degrees. See, so we can write 40 degrees here, which is 85 degrees. Okay, so I hope this question was clear. I mean, this was not a difficult question. You just have to know the isosceles triangle does not always work with a side length. Sometimes you may have to prove the triangle is isosceles using the opposite angles. And once you have proven them as equal to each other, the sides also become equal to each other. Correct. Isosceles triangle has both sides and angles equal to each other. I proved the angles as 50 and 50 degrees, and as a result, I found the sides to be 16 and 16. So I hope this much is clear to everyone. Let's move to our next question. Let's see what that has in the bank. Okay, so this looks like a fairly okay question, not very difficult, um, I would say. Let's see. So we have angle PQM. PQM. Where is PQM? Okay, 42 degrees. All right. Okay. So this is angles in the alternate segment theorem, guys. I mean, if you see here, QM is a chord. This side, QM is a chord, and that chord is making, so this angle will become 42. MS is also a chord, and it's making 25 with the tangent at point of contact. So that will also make 25 here. So that means I have a diagram. I'll draw it separately a little bit. Uh, 1 second. So I have this chord making an angle like this. So obviously these two angles have to be equal. How? Angles in alternate segment. They are equal, correct? Now there's another chord here, and that chord is making 42 degrees. And this chord is joining here as well, and that is 42, right? Don't forget that they have mentioned that MN is a diameter. So diameter makes 90 degree angle, and the angle in the semicircle is 90 degree. So that theorem will also come into the play. Please don't forget angle at the center and angle at the circumference also, guys, right? So if you see, this is point Q, this is point S, this is point O. And we just figured out that this whole angle is what? 42 plus 25, which is 67. So this angle is 67. That means this angle will be what? Twice of it. 2 sevens are 14 and 134. So this angle is 134, right? Now, let's move on to the question. We have 4 parts in this question as well. We'll go part by part. Part number A, option question says angle OQM. So we have OQM, this angle. Oh, that's easy actually. It's 90 degree minus 42 degrees, which is 38 degrees. How? Because OQ is a radius, guys, okay? So the whole angle has to be 90. Radius and tangent makes 90 degree. We saw it in the previous question also, right? Now, B part, angle QNS. So angle QNS. We just saw QNS as 67 degree, guys. 67 degree. We have just proven it here. So you can use this logic. What did we use? Angles in the alternate segment, okay? Option number C. Sorry, part number C. It's not an option. Angle QOS. So QOS, we just figured it out, right? QOS right here. So option number C, QOS is 134 degrees. It's right here. And option number D, sorry, part number D, angle QMS. Where is it? QMS. Okay, so this angle is what they are asking us to find. Please remember, QMS SN is a cyclic quadrilateral. And what do we know about the cyclic quadrilateral? The angles add up to 180 degree. Which angles? The opposite one. So can we say that angle M plus angle N is 180? Therefore, angle M is equals to 180 minus 67, because angle N here is 67. So 3 and 100. So 113 degrees is your answer for QMS. Okay. So I hope this much is clear. I'm using alternate segment theorem in this question. I'm using angle at the center and angle at the circumference. I'm using the radius and tangent at point of contact makes 90 degree. So 3 different theorems were used, and that's why this question is relevant. You have to be multi-dimensional. You can't be just thinking about one particular theorem. Okay, guys? Now, let's move to the next question. All right, so what do we have here? It says it is an isosceles triangle. ABC is an isosceles triangle. That's good. So I will draw the triangle part separately and a little bigger than the original diagram that's given to us. So this angle and this angle should be equal, but they have made an isosceles triangle of their own, right? You remember this is O, this is A, this is C, this and this should be equal. They have also said that this is perpendicular. They have also said that this is 65 and 65. 65 and 65 combined together. So angle AOC is equals to 130 degree. Therefore, what do you guys think angle ABC will be? I think you have guessed it by now. It is 65 degrees. How 65? Because angle at the circumference is half. Okay, so we have that angle. Is there anything else left for us to figure out? Okay, yeah. This whole angle has to be 90 degree because OC, sorry, OC is the radius and this is your tangent. Now, what they have done here is we can figure out this angle as well, 130. So angle OAC is equal to angle OCA is equal to 25 degrees. How do I know it is 25 degrees? Because 180 minus 130 is 50 degrees and it's an isosceles triangle. Don't forget, right? Isosceles triangle means the angles have to be equal. The opposite angles to the equal sides are equal. So 130, you subtract from 180, you'll get 50. You divide that by 2, you'll get 25. They're asking us to find angle BAC, ABC. Okay, so first of all, angle ABC, A part is already found, is equals to 65 degrees. We have just found it here. Second part, they are saying angle BAC. So BAC, the whole of this angle, right? So please remember this is 65, this is 65 because triangle ABC was isosceles. It's given to us, correct? So this is 65, angle B and angle C will also be 65. Therefore, angle A will be how much? 50 degrees. So angle BAC is precisely 50 degrees. Why? 65 plus 65 gives us 130 and 130 subtracted from 180 will give you 55. Okay. So let's move on. Angle BCQ they are asking. Angle BCQ. Okay. So let's see how many angles. So I'm just going to draw that part of the diagram separately. So we have O, we have C, we have this line, we have another line coming here, and we have another line going from here, right? So we figured out that this angle was 25 degrees. See, angle OCA was 25. We have already seen it, established that, okay? Now we have also just found that BAC, meaning this whole angle, no, sorry, not BAC. We also know that this entire angle is 90 degree, correct? And we know that this is 65 and so is this. This whole angle is 65. So this part is 25. So this part will be what, guys? 40 degrees. And that means this will be 50 degrees. Why? Because this is perpendicular. Don't forget. Okay. OC is basically perpendicular to PQ, right? Why? Because radius is perpendicular to the tangent. So 40 degrees from the 65 isosceles triangle, and the remaining angle became 50 degree. Let's see what they're asking. So C part, angle BCQ is what they're asking. BCQ, the outer angle, this angle, which came out as 50 degrees. So this is how you solve this question. What I really used here was uh, once or twice I used isosceles triangle. I also used the radius and the tangent make 90-degree with each other at the point of contact. And rest everything was pretty much basic geometry, equal angles of an isosceles triangle and things like those. So I hope you have all understood this question. Look, guys, see what you have to understand now. By now, you would have definitely seen that happening. In circles, the questions that you are going to solve, uh, there are a few tools that you have to keep in mind before you start solving a question. Okay, every time you start solving a question, you have to keep in mind, okay, I'm going to use isosceles triangle. I'm going to use radius and the tangent. I'm going to use alternate segment theorem. I'm going to use angles in the same segment are equal. I'm going to use angle at the center is twice the angle at the circumference. So there are all in all 8 to 10 different tools, not more than that for sure. So let's count: isosceles triangle, radius and tangent, alternate segment theorem, same segment theorem, angle in a semicircle is 90. You have angle at the center is twice the angle at circumference. You have a cyclic quadrilateral. You have what else? What else? I think I mentioned isosceles triangle already. So see, I'm running out of options now. So roughly I counted to 7 or 8 options, right? So every circle questions precisely just crumbles down and narrows in on these 7 to 8 different principles. So if you're good with them, you'll be good with circles. By now, you should have understood that, okay? Let's move on to the next question. All right, so what do we have here? Okay, so we have a diagram which I'm definitely going to draw a little big. This diagram is a little small for the question. All right, so we have this, we have this. Now, this is a slightly special question, I would say. Why special? Because, first of all, it's a proving question. Any proving question requires a little bit more planning than what we are used to, you know. So, hold on. I think I need to erase this part. Okay, so we have this sort of diagram, guys. Okay, now please remember this is radius at point of contact with the tangent 90-degree. That goes without even saying. Okay, they have joined this point and they have joined this point. Let's mark these points P and Q as they have also mentioned. Now, this question, uh, why is it special? Because if you don't think about constructing something, if you don't think about, you know, going ahead with a particular approach, this question could become a bit harder. They have asked you to prove angle POQ is 90-degree, correct? Now, proving something as 90-degree, that too angle at the center, you very well need either the angle at the circumference to be 90-degree, 45-degree. If that you have, you can solve. But I don't think we have that. So what we're going to do here is we're just going to join this also to just make our life easier. Okay. So I'm going to call this point R. So this is also a radius and makes 90-degree angle. Okay. Now what I'm going to do is I'm going to use triangle OBP and triangle OPR. Okay. Now, if you see, OB should be equals to OR. Why? They're both radii. Okay. OP is equals to OP common. Have some patience, guys. I think you might not understand it yet where I'm heading with this, but trust me, it will open up. Okay, and this is equals to this. Why? Because if you notice from external point P, BP and PR is being constructed. So BP and PR are tangents from an external point. And by theorem, what we know, tangents drawn from an external point are equal in length. And equal till where? Till the point of contact. So this part is equal to this part. So this till point of contact is your tangent. Don't think that the entire line will be your tangent. Only till point of contact. Okay. So we can say that these two triangles are congruent. So I can say triangle OBP is congruent to triangle OPR by SSS. So what it gives us, I'm going to use this as X and this as X. So I can say, therefore, angle BOP is equals to angle POR CPCD. Right? CPCD is everyone's favorite, guys. Come on. I mean, you are solving a congruency question. 99% chances are it is going to be opened by CPCD. Any congruency question you want to solve, always keep in mind CPCD has to eventually come into the play. You have to keep thinking about CPCD in a congruency situation. So I have proven these two angles as equal, X and X. I'm going to use a similar concept on this two triangle. So I can say you when you are writing in board exams, you have to show how these two triangles are going to be congruent, the ones I'm going to write. But I'm not going to prove it as congruent because it's very similar. You have a common side, you have this and this as radius, and you have this side is equal to this side. So they are congruent by, again, SSS. But you have to prove the congruency part, okay? So I'm going to just write similarly triangle OAQ is congruent to triangle OQR, again by SSS. Therefore, I can say that these angles are also equal. I'm going to mark them as Y and Y. So I can say, therefore, angle ROQ is equals to angle QOA is equals to Y. And this was X. Again by what? CPCD. Okay, guys? Now, please understand, AB is a straight line. That means x plus y should give me 180 degrees. If you see here, this whole angle should be 180. Angle on a straight line is 180. So what does that give us? 2x plus 2y is 180. If you take 2 common, you'll get x plus y is equals to 180, and x plus y is equals to 90 with that logic. This 2 will go that side and divide by 180. So x plus y is where exactly? Here. Therefore, angle POQ is equals to 90 degree. So this is a proving question. Good question, special question. If you know that you have to do some external construction, this question becomes so much more easier than what it is, what it looks like, okay? So I hope you have all understood this question as well. I'm just using basic, angles, theorems related to the congruency and CPCT. So nothing really special, nothing very out of the blue. It's not very difficult question, I would say. The only thing you need to understand is that the congruency bit in this particular question has to be thought of, because without congruency, proving this angle as 90 degrees is quite difficult. Okay, I'm not too sure if it is possible also. So I think I have explained this question properly. I hope you've all understood. And remember, guys, whenever these questions are uploaded on the channel, I mean, anytime you feel that there is a doubt, there is something pertaining to the question, there is some part of the question which you're not getting, you can always comment, you can always, drop a message saying that this part can be explained further or not, and I will explain it. That's not really a problem, okay? So I hope this much is clear. So we're going to move to another question. Okay. Yeah, so let's see what we can do here. I'm going to join this. Please understand this is 90 degree. This is 90 degree. The question says that the radius is 8 centimeters. So this is 8, this is 8. Now, if you understand, POQD will be a square. I'm not speculating, guys. I'm going to explain you why it is a square. Because if you see, it's a quadrilateral with three angles is 90 degree. This, and this. That means the fourth angle also has to be 90 degree. So a quadrilateral where adjacent sides are all equal to each other with four 90-degree angles, that's a square, right? That's a square clear as daylight. So this is 8 and 8, and this is also 8 and 8. Okay. They've also said that BC as a whole is 30 centimeter, and BS as a whole is 24. That means this is 24. That means this is 6 because the whole thing is 30. If this is 6, this will be 6. And as a result, DC will be equals to 14 centimeter. This is not a difficult question. But if you don't think about the square bit, and if you're not sure about how BS and BR are equal, you'll not get this question. So please understand BS is equals to BR. How? Tangents from an external point. Okay. Now, and as a result, what happened? How did you get CR as 6? CR became 30 minus 25, which is 6. But then again, CR was equals to CQ. By what logic? Same logic, right? So CR is equals to CQ. And then we have DC is basically equals to CQ plus QD, which is 6 plus 8, which is 14 centimeter. So I hope you guys have understood this much. We will resume with some next set of questions, and we will still continue with the circles. Circles is a huge topic, guys. Please bear with me. I know I'm boring you now, but I'm sure we are going to make one more video on circles, and I think then we are going to move ahead with trigonometry. Okay. So till then, keep rocking, keep preparing for your exams. We'll catch up very soon. Thank you.